It'll start soon. Right. Just tell your friends over WhatsApp that sometimes they don't get the links because of some issues regarding course mailing list and so on. So just tell them that the courses have started and the course has started, and share the Google Meet link with them. So if you have noticed that the Google Meet link for all the classes is going to be the same. Uh, any questions before I start this 0th lecture on 210? Nothing? Okay. Well, let's start with introductions. So it's difficult to introduce everyone here. Well, at least I can introduce myself because you'll be seeing me in all classes. So my name is Gaurav Bhutani. I work at IIT Mandi. I've been here for the last 5 years. And well, in terms of fluid mechanics, I've been dealing with this subject for the last, I would say, 15 plus years. So that was the first time I was introduced to this course on fluid mechanics was a very long time ago when I was a student, BTech student at IIT Kanpur, just like all of you, and in second year. So I mean, this is the entry point to the core courses in mechanical engineering. So it's a very important subject, and that is the reason it's introduced at such an early stage in the core courses in mechanical engineering. Right. So almost all aspects of mechanical engineering will have fluid mechanics in it. Not just mechanical, in fact, all aspects of engineering has some sort of fluid mechanics in it. So fluid mechanics is taught to many other branches as well at different places. Well, introducing myself. So I did my bachelor's and master's both from IIT Kanpur. That was very long time ago. And then I did my PhD from Imperial College London in the field of earth science and engineering, majoring in computational physics. And in the meantime, between PhD and undergraduate, I did work in the industry for 5 years in different kinds of field, including metal mining, data analytics, data science, and that time data science was in the initial stages. So as a mechanical engineer, I got a very nice flavor, and I'll tell you towards the later part when we meet that the combination of mech-eng core and data analytics or data science can be a very nice combo in terms of industrial aspects. Then I also worked briefly in construction. So I've tried my hand at different jobs. I was trying to select by elimination. I also tried applying for armed forces and so on. So I've tried different flavors in finance and banking as well. So 1.5 years I worked in HSBC Bank. Right. That's pretty much about me in terms of my education and work history. Other than that, in terms of hobbies, well, when you come to the campus, you'll see that I do a lot of mountaineering and hiking and trekking. So maybe we'll meet if you like these activities as well. So it's just one thing that please feel free to ask questions in this course. Okay. So the reason I joined this place was to interact with smart people like you. It's always good to be challenged. Okay. So if you make me look like a fool, well, genuinely, not just asking a very difficult question for the sake of it. If you ask difficult questions and I cannot answer them, I'll be happy to read about that and answer in the next day or so on. So that is how I will also learn in this exercise that we're going through together. Don't shy away from asking difficult questions. Usually people don't do that, but if in case that is a tendency, don't do that. I have been teaching other than fluid mechanics. In terms of teaching, I've done continuum mechanics. That's a course that you'll be going through this semester, but I'm not teaching it. Somebody else is doing that. I also teach courses in computational fluid dynamics. That is, we'll talk about that branch. It's a postgraduate level course. I'll talk about computational fluid dynamics during the course of this discussion in this course on fluid mechanics. Other than that, I've been doing some labs in terms of first year computing lab, the fluid mechanics lab that again you'll be going through in your end of third year or fourth year. Then undergraduate course on heat transfer is what I've taught for for the last few years. Mathematics for postgraduates. It's a course that was introduced last year. And lastly, my favorite course is high performance scientific computing. So in terms of research in fluid mechanics, many people, many groups, including ours, they use supercomputers to solve the equations of fluid mechanics for different applications. So we also work on that. We also work towards developing or improving parallelized algorithms that can be run on high performance computing clusters, so that we can solve the equations of fluid mechanics, the partial differential equations of fluid mechanics, in a more efficient and a more tractable manner, to solve industrial level or nature scale problems in fluid mechanics. So we'll again talk more about how fluid mechanics has resulted in the development of computing architecture. It is not the computer scientists who have led to the improvement, it's the mechanical engineers, because ultimately supercomputers were developed to solve computing, to solve engineering problems like weather prediction. That was the major problem. So it has evolved, the hardware has evolved, because there was a demand from mechanical engineers, and mechanical engineers have worked towards evolving the hardware, as we'll talk towards the end of this lecture. Right, so I enjoy writing computer programs in Fortran, C++, and Python. So the kind of applications our research group looks at is called granular flows. So they are complex flows where you have grains of, we look at snow avalanche dynamics, where you have grains of ice and snow. They fall down, or they flow down a slope of a mountain, and we try to understand what is the physics of those flows, and what sort of, how can we mathematically model them as fluids. It's a very interesting application, and similar kind of methods are also applicable in industries. And if you think about it, almost all industries have some sort of granular flows, fluid mechanics happening in them. So that's pretty much a short introduction about myself. I usually ask the students to introduce themselves, but we'll do that when you are back on the campus. It's much more fun to put faces to names. So we'll just hold that for a month, and then we'll have the introductions for all of you. Right. So moving on to the next part of this lecture. Next is details about the lectures. So we'll have a total of 3 lectures per week. So Tuesday, Wednesday, and Thursday. So this is slot F. Okay, so Tuesday we'll have it from 9 to 10. Wednesday it's from 1 to 2 p.m. and Thursday is a bit early. That's 8 to 9. It's only the Wednesday evening one has to be more disciplined. The mode of lectures, as I said, will start with Google Meet, like we have today, and then we'll move to in-person classes when all of you have quarantined and all of you are ready to join the classes. Right. In case somebody cannot come to the campus for any medical reasons and so on, so we are still under transition. So in case that is the case, please let me know well in advance that you are not coming to the campus for certain reasons, with all permissions and so on, so that we can put a camera in the classroom and we can record all the lectures. Okay, so I'm happy to help you, but do let me know well in advance if you're not coming to the campus. If you're on the campus, then you're expected to come to the classes when we start the in-person classes. But I'll let you know when that happens, well, at least a week in advance. Right, so this is about lectures. This course, we'll have some tutorials as well. So every 2 weeks, I'll try to do one tutorial, particularly when you're back on the campus. Again, tutorials are more useful if we can have the tutor, we can have me walking around in the class and just try to solve problems. At home, online, it's better if you just solve the assignment by yourself and come back to me if you have any questions over emails. Okay, so tutorials, we'll start these sessions after April. I'll still share the tutorial sheets with you for practice. Tutorials will happen on the Wednesday session, that is from 1 to 2 p.m. I really want all of you to be present in the tutorial. So in case you are not able to get up in the mornings, Wednesday session will definitely be possible. Right. So in terms of communication, all the official communication, for example, the course link and so on, will be sent to you on the course mailing list. So again, you are well aware of that. Okay, so that is ME210 at students.iitmandi.ac.in. Yeah, so we will have, I'll send you, so you must have got, I think, one email recently which had details about the classes starting and so on. If you have not received that link, then please let me know. I will enroll you to this mailing list. Self-enrollment is also possible. For the first 1 or 2 weeks, I'll do the enrollments in case you're not enrolled. After that, I'll ask you to enroll yourself because it's all based on Google Groups. Then the other forum that we'll be using a lot for regular discussions is called Google Chat. So over the past 2 years, well, 1.5 years during the pandemic, we've realized that these forums can also be quite effective for, especially for you people to interact with each other for academic discussions. Okay, so Google Chat, again, I added the batch mailing list to it. So many of you have enrolled to Google Chat. If you haven't done that, do it. You can search for Google Chat, search for ME210. You will get something. If you can't figure it out, let me know. I'll add you manually. So Google Chat is primarily for discussing academic matters. I will not use it for official communication. So if I'm talking about, I'm communicating an exam date, I'll do that on the course mailing list, not the Google Chat link. But if I'm sending some interesting video to watch, which is related to academics, then I'll send it on Google Chat. Right, and you can ask questions that you are confused about. Then your friends can read it, answer it. So it has all these options of creating threads and so on. Right, so please make use of it. If you don't use it, just browse through it so that you don't miss on any interesting things. Right, the other forum that we'll be using is Moodle. Again, all of you are used to using Moodle. You have had your exams and evaluations on Moodle as well, I guess. So Moodle, again, Moodle server, this students.iitmandi.ac.in/Moodle. Okay, the course has been created there. I'll ask you to enroll yourself. The course material, for example, PDF of lecture notes until we are doing these things online. Once we start offline, then there's no PDF. You have to attend the classes. So until things are going online, all the PDFs and so on will be uploaded on Moodle. All tutorial assignments at all times will be uploaded on Moodle, and any other material related to the course will be there on Moodle. Including the link for YouTube link for where I'll be uploading these videos for the sessions until they're happening online. Right, so please enroll yourself, and towards the beginning we might have a minor quiz before you come back on the campus. So that quiz again will happen on Moodle. So it's very important you enroll yourself for the course. Okay, any questions regarding mailing lists, communications, and so on? Okay, if everybody's happy, then we'll move on. Accessing lecture materials, as I mentioned, you'll have lecture notes. as PDF. Lecture notes, as in like these, whatever I'm scribbling on the board. The notes I make for myself are only for myself. You can't understand that anyways. I have very bad writing when I make my own notes. Okay. So don't worry about that. Most of the notes are from the textbook only. So I'll tell you about the textbook soon. Okay, lecture videos. Then you'll have reading assignments. Okay, so whenever I discuss some, I mean, let's say I discuss a couple of topics today and this week. So towards the end of the week, I will upload uh, reading assignments on Moodle. So they'll basically be section numbers from the book where we have covered the topics. So towards the end of the week, you will get some section numbers. You can always read those and stay up to speed with what we are covering from the book. Okay, so these are basically section numbers from the book related to the topics we have covered during the course of the week. So they're very useful. I mean, that help you complement something. So not everything cannot be discussed in the lectures, but books sometimes will go into certain details that you might enjoy, and that might be helpful for you. And also, it's good to develop the habit of reading books rather than depending on the instructor completely. Okay, so reading assignments will be uploaded. These are basically book sections. From textbook. Then, as I mentioned, tutorial sheets. So you'll have approximately 6 sheets in the course. So all these will be available on Moodle. And lectures and tutorials will be complementing each other. It's not that if you have attended the lectures, tutorials are not important. Okay, that is not the case. In fact, a lot of learning will happen through tutorials as well. So in lectures, I'll tell you about the concepts, equations, ideas, but tutorials is where you'll implement them on problems and that you'll be expected to solve during the exam. So it can be expected that if you don't attend the tutorials, you'll not be able to solve the problems in the exam. So please do attend tutorials, or if you do not want to attend them, at least solve the tutorial sheets so that you understand what sort of problems you'll be expected in the exam and what sort of problems you'll be expected to solve when you go to the industry. So they're very similar. And sometimes tutorial problems will be very detailed. So there'll be some learning through the problem as well. When you read the problem, which is 2 paragraph long, the first paragraph will talk about the application of fluid mechanics in wind turbines. So what are the different parts available in a wind turbine, and what sort of design is required, and that paragraph will tell you some idea, some application of fluid mechanics and some detail about the application, and then you will get the problem that you have to solve by putting numbers and so on. Okay, so tutorial problems by itself are complementing the lectures. Okay, so this is pretty much about the material for the lecture. Next comes expectations. So my expectations from you, and then your expectations from me and from the course. So let us start with your expectations. So I would want you to tell me what your expectations are in terms of this course and from me in this course. Feel free to speak up. Yes, Yuvraj.
So in this course, we'll be doing some simulations and answers or something else, or it will be completely theoretical course.
It will be theoretical. So it's a first level course in fluid mechanics. So ANSYS simulations are more of hands-on exercise with working with the tool.
Yes, sir.
So that is not a part of this course. I will give a brief introduction. But we have a 10% course project in this course. So you can learn those things and apply those things through that project. But
So,
classrooms will not discuss or there's no expected simulation part in this course.
okay, sir.
So it's a theoretical course, first level course. You will develop your fundamentals of fluid mechanics, including different ideas, which include mathematical equations, which includes experimental understanding of experimental data, and some correlations that are developed. So it's not just purely theoretical. You'll also learn some applied ideas, but no simulation as such as a part of this course.
Also, are we going to discuss some research paper? Are we going?
Again, no. So this is a first level course, but as I said that there's a term project or course project towards the end of the course. So use that for exploring these extra things, because these things will only make sense if our fundamentals are rigid and strong, not rigid, strong. This is all about developing those fundamentals. But if you are interested in these things, or if you get interested in these things towards the later part of the course, we have advanced courses available in fluid mechanics and related fields, so you can explore those. But this course will be focused on developing a strong foundation in the field.
Okay, sir. Thank you so much.
But once you go through this course, you will be equipped to understand what is there in these research papers and so on. So feel free to explore these things yourself. Again, I mean, you should be driving your education anyways by yourself. So if you like these things, explore them, read them, go through YouTube videos. Nowadays, it's become a habit for researchers to make short 3 to 5 minute videos on their research, where they summarize everything. So you can even go through those, subscribe to those channels on YouTube, and they're very useful. So do that. Discuss on Google Chat with your classmates, and discuss with me if you like. And we can always discuss them in class. Once a week, towards the end of a class, we can have this discussion when things start offline.
Okay, sir. Thank you so much.
Thanks. Any other questions, expectations? Right. Well, whenever you have any question, or whenever you want to uh, discuss any expectation that you have from me or from the course, please do let me know. I'll be happy to address those. Right. So, what are my expectations? Okay. I have a lot of expectations from you people. The first one is to enjoy the course. It's sounds very cliche, but I do want to mention it because over the period of time we forget about the fact that we have to enjoy this course as well. We just want things to finish. That happens with many people. For many reasons, but it's very important you enjoy it, because it's a fundamental course in mechanical engineering or engineering in general. If you don't enjoy it, then you will not be able to get the maximum out of it. Now, if you are not able to enjoy it, then something is going wrong, because this is a fun course in terms of whatever stuff it has. So if you are not able to enjoy it, then you have to let me know in the class or over an email, so that I can figure out what is going wrong. Maybe I have made the classes too monotonous in terms of derivation on the board and so on, and then you have lost all track of the fun that was part of it. Okay, so let me know. Then we'll do some. I'll evolve. I need that feedback. If you've stopped enjoying the course, it's not just because of you. It's sometimes because of me as well, that the enjoyment stops during the course of lectures as we go further through the semester. Okay, the other is to learn this course sincerely. I'll call it sincere effort. Give your sincere efforts. At times, this course may become quite mathematical. The mathematical ideas you may see may seem too evolved, although they are not. But it happens that we get intimidated by the equations, especially if you miss a lecture for some reason, and next lecture you suddenly see a partial differential equation, which has lots of terms which do not make any sense. Keep at it. Okay, if you cannot understand things, still keep attending the lectures. Hear out whatever is happening in the lecture, ask questions, discuss with your friends, talk to me, uh, and I can assure you that if you don't understand something in a lecture, towards the end of the course, things will start making sense. I'm not saying that everything will make sense only towards the end of the course, but what I'm saying is that sometimes it does happen that what you hear in a given lecture um, gets, gets clear only after a few lectures, and then you have that aha moment. Ah, that is like what exactly it was. Okay? And you can only have that aha moment if you have been through the previous lectures. Okay, this is a core course. Please don't give up. Give your sincere effort, and I can assure you that things will make sense and you will be fulfilled towards the end of the course. And the reason is because it is important, very important for mechanical engineering students, a mechanical engineering trade, right? It's important for interviews. I must write that. Okay, so in the future, when you sit for interviews, and it is happening that engineering jobs are slowly after they've started coming back in the domain. So in the next 5 or 10 years, most of the high-paying jobs will again be engineering jobs, intermingled with some skills of data analytics and so on. So the core knowledge is what will pay you a lot, because you can learn to program at any stage, but engineering knowledge requires years of effort, like what you're going through. So anybody can you cannot do a 6 months course in mechanical engineering and then start working in a job that is in related domain. So engineering jobs are picking up, and you know that we're training you for the future, not for what's happening today or in the past. So looking at what will happen in the future, engineering will is picking up now. So please, I mean, this course is also important for interviews. Any mechanical core interview will expect you to know um, about fluid mechanics. Okay. The other thing is to relate the ideas to real world applications. And again, for engineers, this is very important when you learn any subject. For instance, I mean, let's say you're learning fluid mechanics, and then you come across a pipeline. You're walking on the campus and you see this cooling tower with some interesting intricate pipeline which have different thicknesses. A thick pipe starts, and then two thin pipes come out of it, and then you relate it to what you have been learning. You say that recently I learned about volume flow rate affects the pressure drop, how a pressure drop or a pump is designed. So then you think about it, would I need a bigger pump for thinner pipes or thicker pipes? Okay, so whatever ideas you go through, whatever topics you go through in the lectures or the tutorials, do relate them to real world. Only then your engineering intuition or engineering common sense will evolve. Because if you just try to solve problems in the classroom and then forget about the course, you will forget about this by the time you are about to graduate and sit in interviews. Okay, so keep doing that, and that in fact should be a habit. Train yourself to enjoy applying the ideas, and then you can even show off to your friends outside IITs and so on. So that is that can be conversation starter, whatever it is. But you can always relate your classroom ideas to real world. You see a windmill while you are driving through, let's say, Tamil Nadu, and you see a windmill, a wind farm. You try to relate the ideas. Okay, lots of windmills, but does the positioning, relative positioning of windmills has any effect? Is there a wake region behind a windmill that can affect the efficiency of other windmills? Let's think about these ideas. Why are they patterned like a star, or why are they aligned all in a line? So question these from the technical perspective. And even if you think about the question, don't even answer the question. Just generate that question in the mind and then ask it to someone. And in the process of generating the question and asking it to your friends or colleagues, you will see that your brain will start making those connections. And I mean, you're welcome to generate the questions even before you learn these things in the class. So whatever you see related to fluid mechanics, you should always ask when you're driving to the campus, and you see, I mean, you ask the driver what the mileage of the car is, and then you think of a truck, I mean, or a car which is, let's say, you compare Maruti Gypsy with Swift, Maruti Suzuki Swift, and you see that which one Swift has more mileage. But does the shape have to do anything with it? Of course, it has. But then you think about how could I estimate using the ideas I will learn in the course or I have learned in the course to estimate the drag force and then finally estimate the mileage, assuming let's say they have the same engine in the car. Okay, so these ideas are very important, and they only will get reinforced if you ask these questions. So this should become a habit in general to ask questions like this, or let them get generated. No, not just solve them, but let them get generated, and they will automatically be solved when you discuss with your friends and so on. And do have that discussion. I know that you are still off the campus, but when you're back on the campus, again, make it a habit to have technical discussions with your friends. So the reason I'll just tell you the reason that IITs and IIMs are the top colleges in the world, not just India, is not because they have extremely talented faculty members. They do have, but that is not the major reason. The major reason these colleges are really good in terms of education are because of the peer-to-peer learning. So what we are smart enough to take smart students who make each other smarter during the course of 4 years. If you do not talk to each other at all in those 4 years, then you will not be as smart as the students who interact. So you have the peer-to-peer learning has significant effect on the quality of your education as compared to the instructor to student learning. That can, I mean, you can have much better instructors if you go to MIT courseware and so on, but just the peer-to-peer learning that will be more sustainable. So please do have that discussions online, and when the things start in person, then have them in person, right? You'll be in the mountains, so you'll have wind flows, you'll have river flows. So when you see a rock in the river and you see that intricate pattern around the rock, you should definitely compare that with the ideas of turbulence that we discuss towards the end of this course, right? So that's um, one expectation I have from you, to relate things, ideas to the real world applications. And as I said, seek help from me if you have any issues with, let's say, mathematics, etc., that I would expect to be a prerequisite for you, but you still you're not able to recall, or you didn't pay enough focus during your first year course. That is okay. I mean, it's we all do that. So let me know so that I can give you some material, or I can give you a short refresher course in those topics so that you can get up. My job is to make sure you understand fluid mechanics. Yeah, I will not criticize you for not studying your mathematics properly. If you have not done that, then I will teach you so that you can learn my course properly. Any comments? Okay, prerequisites. There are no prerequisites for this course, except I mean, you should have been through your first year courses anyways. Uh, Thermodynamics, I think everybody has gone through it. So that again is an unsaid prerequisite for this course, but we won't be doing much of thermodynamics anyways, because thermodynamics is about stationary states, but this is a lot of dynamics happening. But we'll discuss that, but you won't need it too much. But I might use some language of thermodynamics. So if you don't understand it, do raise your hand and I'll clarify that. Yes, Shashwat.
Sir, like in case if we have any doubts, so can we stay back after the class and discuss?
Sure, you can do that. I mean, you're always welcome.
Okay,
So
sir.
that's quite mature. I mean, if you don't, if you think that that is going to slow down the class and so on, but you can feel free to ask during the class. Yeah, that is recommended because most of us don't realize, but your question is also the question. I mean, for many others as well. So I'll encourage you to ask questions during the class. But if for some reason the class is about to finish and so on, you're welcome to stay after the class and discuss.
Okay, sir. Thank you.
So for all lectures, I'll keep half an hour after the class. I do keep that usually for such discussions. And in-person classes, anyways, one has to walk to the classroom and so on. So extra 1 hour after the class is always free. So you're welcome to ask questions. And you can, I'll have some course hours where you can drop into my office and ask questions. And if you would want to come to my office at a short notice, again, we have this class chat. Just drop in a message and I'll let you know if I'm in the office. If not, then I'll give you some time. But it's a residential campus we live in. So we can always meet up in the canteen in the evening. So I'll be walking around the campus. You'll be walking around the campus. So we'll end up seeing each other at off hours as well. So feel free to discuss your questions anytime. Any other questions? Right. So the next topic I would want to discuss in the 0th lecture is about feedback. Okay, so the feedback, the reason I mentioned explicitly about this is because I want this feedback to be two-way, in the sense that I want you to give me feedback during the course, and I'll also give you feedback during the course. Okay, so let's talk about me giving you feedback. So you will get feedback from me through tutorials. So when we are doing tutorials in person, then you'll be solving problems in the class, and I'll be walking around. I'll be looking at what you're doing, and I'll give you feedback that why don't you look at the lecture that we discussed a couple of weeks ago? You will get some idea and so on. So if you do something wrong, then I'll point it out in the tutorials. So that's a feedback from the instructor to the students. The other feedback that you will get is through quizzes. So you'll have 2 quizzes and 1 end-sem. You'll get that feedback. You'll also have 2 minor quizzes. I'll talk about them soon. So those 2 5% quizzes, they'll be also I'll be using them to give you feedback. Okay, the other forum is the course project or the term project. So you can see that there are quite a few avenues of you getting feedback from me. And feedback is not just evaluating you. Feedback is about telling you where you might be making a mistake or doing things incorrectly so that you can improve. The reason we are doing all this is so that by the end of this one semester, you have a good understanding of fluid mechanics. So if you make mistakes, then it's good so that if I can catch them, I can tell you what is going wrong and then you can correct them. So that feedback is very important for you. So when you get a quiz copy, do go through it. Don't just see the marks and be happy about it. Okay? There will be some comments on the paper that I may have written. So read them and feel free to discuss. So that written feedback is going to be very important for you. The other is me getting feedback from you. That again is very important because see every class is different, every instructor is different, and every instructor is evolving in the way they teach. And the students also are evolving. So the way students used to learn 5 years ago is very different from the way you learn. So you have to give me feedback so that I can improve or I can evolve the way of teaching that is most effective for you people. So the avenues for that will be minor quizzes. So these minor quizzes will also help me understand how well you are understanding the topics that are being taught in the class. The other is I'll be having some sort of feedback sessions. Let's say 2 sessions in the whole semester, where I will be asking you. In the class, I'll be giving you some questionnaire. You can use your mobile phones and fill in the feedback, and then that feedback will be visible on the board. So we'll get a quick feedback about something. Okay, tutorials again are I mean, not that's a feedback for you. The other is if you have any questions you ask in the class, that's again a feedback for me, and you can always send emails if you have any comments or critical comments or feedback. So I'll be happy to. I mean, that is actually quite helpful. So if you think that there is something seriously wrong or something can be improved, do drop in that email. Don't be shy. I mean, if I don't like it, I will address it and then not change anything, but at least I will go through whatever you suggest. Right. So I was going to have a short feedback session in the sense of getting your initial understanding, but let us do towards the end if we have time. So we'll put a star here and come back to it. Right. Textbooks. A textbook. So the textbook for this course is F.M. White. I'm using the 8th international edition, but 8th edition or later is okay. So whenever I give any tutorial problems coming from the book, then I'll mention which edition, the question number from the edition, or I will put a PDF attached so that you can read the problem. But in most cases, the problem will be typed in the problem sheet only. Okay, ebook is available in the library. So I will upload a copy of ebook on Moodle for this semester, and a couple of hard copies. In fact, quite a few hard copies are also available in the library. So if you like having hard copies for books, then you can issue them from the library. And if you have any issues issuing the book from the library, then do let me know. I'll check with them. We have quite a few reference books. So there's no order of preference for these books that I'm going to write. Uh, so you can explore them whenever you feel like. So one's called Kundu and Cohen. That's a very nice book. And all of these are in some way advanced books. They're not undergraduate books, but some topics can be clarified. If you really like something, you can always go into detail in these books. The other one is GK Bachelor. Okay, GK Bachelor has been written in a very compact form, and it's actually for its advanced plus stages. But again, I mean, if you feel like you can always be adventurous, then Muralidhar, it's a good book. I mean, Muralidhar in fact taught me fluid mechanics, the first level fluid mechanics when I was a student. So that's particularly why I like this book. The other is called Schlichting. I hope I've written the spelling correctly. So this one's particularly about boundary layers. Again, we talk about them day after tomorrow. Then there's a book by Van Dyke. It's pictures only. So it's very interesting. I always show this book to the students in the class. So I'll do that here as well. Again, this book I'll upload on Moodle for you to explore. So I hope you can see my screen now with the book on it. It's called An Album of Fluid Motion.
Yes, sir, it's visible.
Okay, great. So this book was published in 1982 for the first time, and it's edited in 80s only. So it's a very good book in the sense that it has lots of pictures. And believe me, I mean, getting these pictures is very difficult. I mean, it's a very challenging task. It's a very meticulous way of conducting experiments to get pictures like this. So you will be going through topics, for example, on laminar flows. So just explore, just browse through this book. I'm not sure if the library has a copy. I ordered one some time ago, but getting hard copies for these old books is very difficult. So the idea, whatever you see is actual experiment. And nowadays, people will be doing computer simulations to get equations, solve them, but this is real hardcore experiments. So I mean, I would when I was a student, I got this in my library in Kanpur, and I would simply browse through the book. I just loved it. Okay, just go through it for the sake of looking at pictures, and then when you go through a certain topic, you will be able to relate the ideas that we discuss in the class with what you are seeing here. So the equations, mathematical equations of flow past a sphere or or a cylinder and so on will be apparent. These vortices that you can see, for example, on the top. Okay, these twin vortices which are stuck to the body. So all these will make a lot of sense. Okay, so please, a sincere suggestion to go through this book. You will definitely enjoy it. Okay, these experiments were done at Stanford University in 80s. The other one is FYFD website. Okay. You may have got a video that I shared yesterday that was simply to introduce you to this website. So it's like a website where people upload latest research related to fluid mechanics. So just browse through it. For example, I found the article of the layer of the liquid layer that forms below the ice skates, between the ice skate and the ice layer in the ice rink when people go for ice skating. So why is it that for ice skating, the friction between the ice and the knife edge is very low? So people do all sort of interesting experimental researches and upload it there. So if you like the subject, then you should definitely explore the website. And again, don't stress yourself with reading everything. Just look at the articles, just browse through it like you do in Twitter and so on, and get introduced to these things in this first level course. And I will share videos with you. I'll call it GBS Material, such as videos, articles, and so on. So do go through them. In some cases, I'll say that definitely go through them because you might be asked questions about them in the exam. So then you should definitely focus on those articles. Right, grading policy. So for this course, we will have a total of 6 evaluations. So the first one, we'll have 2 major quizzes, quiz 1 and quiz 2. Each will be 20% in weight. And all the exams, all these 3 exams, including quiz 1, quiz 2, and NSEM, will be conducted during the standard exam times. So this is ours is slot F. So please check the timetable and make sure whenever the date for the exam is. But I'll definitely send you an email a couple of weeks before the exam is about to be conducted. So this is, and all these are subjective. So now we're talking about solving real world problems. So in real life, you don't even get the problem. You have to formulate the problem and then solve it. So objectiveness in the exams has to evolve to subjectiveness. And slowly you will see projects will end up not even tell you the problem. They just give you a topic and you have to figure out the problems by yourself as well. And then we'll have 2 minor quizzes. So minor quiz A and minor quiz B. Okay, so these are only 5% each. And as I said that the major reason I have them is for me to get feedback as to how well I'm teaching. So I'll ask you a couple of questions, and these are all objective. And if I see that all of you can answer these questions, then I'll be happy that I'm doing my job properly. So these are mostly based on fundamental ideas. So if you are attending the classes, you understand whatever's happening in the class lectures, then you should be able to do well. And most of you will get 5 out of 5 in these because these are very simple and basic ideas. Okay, this is mainly for me to get feedback from you. And then we have a course project. So the placement of this project is between quiz 2 and NSIM, as you can see. Okay, so this will be 10%. I think that adds 20, 20, 40, 80, 90, 100. Yeah. And again, I will discuss more about it later. But mainly this is for you to whatever, if you, I had some questions about reading papers and ANSYS, some CFD simulations and so on. So all this will be discussed under the topic on course project. So we'll discuss it, but you can explore these things. So you can keep exploring over the course, over the time in this course, and then apply that in the course project. But I'll discuss this when you're back on the campus in April. Until then, you just follow the lectures. Right. So that's pretty much in terms of grading policy. Is there any questions or anybody has any concerns about the policy? Please discuss them. Otherwise, we'll finalize it today in the class.
Excuse me, sir.
Yes, please.
So, माइनर क्विज ए एंड माइनस क्विज बी का जो परसेंटेज है वो 10% नहीं हो सकता, लाइक 10-10, बिकॉज इट विल रिड्यूस आवर, मतलब आंसर में अगर हम मेजॉरिटी पोर्शन खो देते हैं किसी रीजन से, so we will end up having a low grade. So,
well, NSEM is 40%. So typically NSEMs are 50% or more. So firstly, the first answer to your question is NSEM is only 40%. The second question is, can we increase the weight of minor quiz A? The reason I won't do it is because it's a feedback quiz, an objective in nature. So I would want to put major weight to quizzes which are more subjective in nature. And I mean, don't worry. I mean, NSEM anyways, you'll have to summarize the whole course, because I would want to make sure that you have understood the basic idea. So NSEM, so quizzes 1 and 2 will have more focused questions, but NSEM will be about the general understanding. So everything that you, all the derivations and all, for example, will not be required. I won't require you to understand, remember them and so on. NSEM is more about if you have solved the tutorial problems, you understand them, then you should be able to do the NSEM properly. So NSEM is about summarizing the knowledge that we have gained over the course. So don't worry, you won't have a lot of stress for the NSEM because it's only 40% firstly, and secondly, the problems will not be too detailed. They'll be about the summarizing knowledge that you are expected to learn from the course. I'll not stress you in the NSEM, don't worry.
okay, sir. Thank you so much.
So,
Yes, sir.
so like, can we have more focus on the course project, like, increasing the weightage or something?
See, it's a second level course. It is not recommended to put too much weight to course project, because if I do that, then the understanding of the basic ideas has less weight. I would suggest not to do it, but if you have a 4-level course or advanced courses, there the course projects can be can have a significant weight. But you have no idea about fluid mechanics till now, no idea about continuum mechanics. So giving weight to course project will simply dilute the focus on the theoretical and the analytical ideas. So let us not do that. But if you have a strong interest in the project, then you can discuss that with me. And then in higher level courses, we have an advanced course called ME603, Advanced Fluid Mechanics. You can take that up next year and continue the project as a part, because that course will definitely have some significant weight given to the course project. Okay, but for second level course like this, it is I will have to strongly justify the need for having a course project, but I myself do not feel that it is justifiable at this stage. I'm sorry for that. I cannot increase.
Okay, sir. Thank you. And sir, I had one more doubt regarding the books. So can we also refer to the book by Sengel and Simbala, Fluid Mechanics?
Yeah, please. I mean, feel free to refer to any book. There's lots of books available in fluid mechanics. Refer to any book you like. So I'm not stopping you from referring to any book. These are the ones I have copies for and I like personally, but you can refer to any book you want. Okay.
Okay, sir. Thank you.
When you ask questions particularly from a book, then do let me know which book it is so that I can read that. But I will never stop you from referring to any book. And if you like a book, then do let me know. I will also buy a copy for that.
Yes, sir. Sure.
And this quiz A, we'll be having it over Moodle. Okay, so this will happen before you come back to the campus. The rest of the quizzes will be happening in person. So no Moodle. So are we happy in general about the examination policy? I think we're out of time now, so we'll stop here. If anybody has a concern, you have 10 more seconds to speak up. Otherwise, we will freeze this grading policy for the whole semester. Good. So it's very good that you are happy and we have decided over a policy. So we'll meet again tomorrow, and in the meantime, do go through the videos I've shared on the Google chat, and I'll keep sharing more stuff there. Okay, thank you very much. I'll see you tomorrow at 1 p.m.
Thank you, sir.
Do you have any core course after this class?
No, sir.
So, if in the future I go beyond 10 for continuity reasons, then nobody will have issues, right?
Yes, sir.